use this strategy of questioning, first of all, is the equation our quadratic equation? Remember, so we're really dealing with quadratics here, but in the long run, I want you to be able to look at any equation and identify whether it's quadratic or not. And again, in this section, we're only going to be dealing with quadratic functions, quadratic equations. So yes, they're all going to be quadratic. The question, though, that you would ask next would be, is the equation in standard form? And just to remind you, standard form would be when all of the terms are on one side of the equals sign, one side of the equation, and they are listed in order from the highest power down to the lowest power. So the x squared term, that's the quadratic, then the linear term, that's x to the first power, and then the constant, and then equals 0. So this equation here in number 11 is not in standard form, so we're going to want to put it into standard form. So we have 2x squared by subtracting 3 from both sides, minus x minus 3 equals 0. Once we get the equation in standard form, then we have to factor. That's this strategy anyway. This is the factoring. We're going to try factoring, and all of the equations in this section will be able to be solved by factoring. So sometimes we have quadratic equations that cannot be solved by factoring, and then we would use the quadratic formula, which is what we're going to learn next. Anyway, each of these polynomials can be factored. So using the FOIL method, 2x times x is 2x squared. 1 times 3 is 3. Negative 3 and a positive 1. If we check, we get just making sure we get the right factors. 2x squared, 2x and negative 3x is negative x, and then we have minus 3. If this is where you're struggling, then your struggle is not with the new lesson, solving by factoring, it's just by factoring. So we can deal with that at a different time. But in this particular video, we're going to be focusing mainly on solving by factoring. So once you get the factors correct, then you set each factor equal to 0, and then solve each of the resulting equations. So we have 2x minus 3 equals 0, adding 3 to both sides, and then dividing both sides by 2 gives us x is equal to 3 halves. Over here, we can subtract 1 from both sides, and we get x is equal to negative 1. So we have the two solutions to the equation given in problem 11. And then for problem 13, is the equation in standard form? No. So we're going to add 4 to both sides. Now, this particular equation, you can simplify your life a little bit. Let's first get it in standard form. Simplifying your life a little bit would be using that property where you can divide every real number in an equation by the same real number, and you're not changing the solutions, you're just changing the look. So 2 divided by 2 is 1. 6 divided by 2 is 3, 3 over 1. 4 divided by 2 is 2, or you can think of this as 2 goes into 4 2 times, 2 goes into 2 goes into 2 1 time, and then 0 divided by 2 is just 0. So the reason why we wanted to do that is because now it becomes a much easier equation to solve, but easier polynomial on the left side of the equal sign to factor. So we have x times x, we have 2 times 1, plus and plus. Setting each factor equal to 0, we get x plus 1 equals 0 and x plus 2 equals 0, which means x is equal to negative 1 and x is equal to negative 2. Those two real numbers make the original equation true. And if you were to check, I think it'd be worthwhile just to check, just to make sure, plugging negative 1 into the original equation, substituting in negative 1. We're just checking, just to show you what this all actually means. And we get 2 times negative 1 squared. So again, all we did was we replaced x in the original equation with one of the solutions that we said is a solution. So it should make the equation true. So the question is, is this equation true by placing a negative 1 in place of the x? So 2 times negative 1 squared is 2. 6 times negative 1 is negative 6. And does that equal negative 4? Yes, negative 4 does equal negative 4. If we did the same thing with the negative 2, then we would replace x with negative 2 and ask ourselves, does that equate, or is that equation true? 2 times negative 2 squared. So negative 2 squared is 4. 2 times 4 is 8. Oops, writing it so you can't see. And then plus 6 times negative 2. So 6 times negative 2 is negative 12. Plus a negative 12 is the same as minus 12. And so that is true as well. So if you tried to replace x with anything but negative 1 and negative 2, you would be unsuccessful. You would see that any other real number would make this equation a false equation. But if you replace x with either of these two real numbers, then you would get a true equation. You'd get an equation that is actually true. And then I guess before we sign off on this video, let's go ahead and solve number 14. Number 14 is not in standard form, so we will put it into standard form by subtracting 16x and subtracting 12 from both sides. So we get 3x squared minus 16x minus 12 is equal to 0. And again, it's in the solve by factoring section, so most likely it will factor 3x and x. What if we put a 4 and a 2? That's not going to work. How about 6 and a 2? Yeah, that works. So 6 and 2, so we get 3x times negative 6 is negative 18x, and then we get positive 2x. That gives us our negative 16x. Check. So we got the correct factors, and then we're going to set those factors equal to 0. And with a little bit of work, subtract 2, divide by 3, and we would get negative 2/3. Add 6 to both sides, and we would get positive 6. And you could check for yourself to see if those two solutions make the original equation true, and you would see that they do. That's it for this video.